Right, so today I'm just going to prove that the area of a triangle is half the height multiplied by the base, or in this case, half AB multiplied by BC. So what we have here is a right angle triangle, and what I'm going to do with this right angle triangle is I'm actually going to make a rectangle from it. So what we're really doing here is we're just going to flip around a triangle. So we'll call this point B dash, and as B is 90 degrees, B dash will also be 90 degrees. But what I'm going to just do here now is I'm just going to prove that this is actually a rectangle. So to do that, I'm just going to call this angle 1, and we know that this angle is 90 degrees and that all angles added together in a triangle add up to 180. So if this is 90, then the sum of these two angles will also have to be 90. So we know that this angle here is going to be 90 degrees minus angle 1. So then now when we flip over our triangle, angle 1 is now in here, and then 90 degrees minus angle 1 is now in here. So if we sum these together, 90 degrees minus angle 1, two of these will cancel each other out, and that this angle here will be 90 degrees. And the same thing happens up here. Right, so now if we look at this logically, the area of this triangle, ABC, is going to be half the area of the rectangle ABCB dash, isn't it? So we'll write that down, half the area of A, B, C, and B dash. Right, so we know that the formula for achieving the area, or for finding out the area of a rectangle, is the height or by the base, or the length by the width, whatever way you want to call it. So we'll write that down. So area of a rectangle, sorry, it's not the best writing in the world, but equals AB multiplied by BC. So now, to find the area of this triangle, all we have to do is half this here. So if we go half AB multiplied by BC, that will give us the area of a right angle triangle. And that is also the formula that we ended up with up here. So area of triangle equals half AB plus BC. And the reason that this formula works for any triangle that we're looking to find the area of is because of a theorem I discussed earlier in an earlier video, that the triangles between parallel lines that share the same base are equal in area. So if we were to drag this point, or say we had a triangle with a point here, and that was our triangle there, all we'd have to do is drag this point over to here until we had a 90-degree angle in our triangle, and then we could go through the same process again and prove that that the formula for achieving the area of a triangle is equal to half the height by the base.